So as Tayab already told, and also Raphael, well, to bring all these concepts into one common framework, the first what we did was to specify 22 use cases pertaining to each of the time frames that we were looking at the dream project. So the first, more or less the commercial, the day ahead and market-related part, then to the more near real time, let's say in the order of quarter of an hour's spectrum of operation, and finally also the use cases on the establishing a real-time response. And we came to 22 use cases that we collected, and with UML, that's, let's say, the standard in information engineering, we tried to bring all these use cases together. And in UML, you focus mostly on three things of the operation. First is on the data and the classes. Secondly, on the behavior. So what is the sequence of operations and the interaction between different objects in your system. And finally, also the deployment is very important. So you make diagrams in order to combine these 22 use cases. And so that's the first thing that we did during the first 2 years of the project. And we also specified architectural structure and constraints. So the constraints are related to timing, to response times, and what you can imagine. Furthermore, we had to ensure that the prototypes were interoperable, so that it was possible to be sure that let's say, the real-time methods and operations were not conflicting with market operations regarding the time frames and the ICT requirements. And furthermore, we defined a set of common capabilities. So what can you do with the collection of the software that you are have developed during the first 3 working packages?
It's like ice cream, right?
Okay. And then finally, we also put into perspective the instantiation of the prototypes to a number of different versions of the software. So if you look at Windows, you have a number of versions of Windows. And if you look at this framework, you have a lot of different instantiations, as we call it, a lot of version. Very specific to a number of field test environments, but also the field tests which are actually executed. So this is what we came to with the Dream framework. So we have a layered architecture. So we start at the bottom with the information and communication network. Then we had a number of libraries, as to speak, called packages, which have to do with monitoring and control, persistence, so that's data storage and what data is needed at what location, at what time. Then an important aspect is the coordination topology and the setup. And from that we came to more general things like forecasting, flexibility utilization and coordination. And that's one of the things that's very important, especially to the Dream framework. And with that we were able to serve commercial operations and distribution system operation. In order to guarantee the consistency of the model, we also developed a continuous integration trajectory and also an automated validation trajectory with state-of-the-art tools used in software engineering environments. So if you look at the implementation status, we have the framework implemented. And also we came to a number of add-ons which we detected and specified during the project. And what was very handy was a grid manager and a grid point visualization tool, especially from the point of serving different field tests, and some of the visualizations you can see or already have seen in the previous lectures and the following lectures. Furthermore, we worked on load flow, implementing in the framework load flow computations, and also a measurement API, so one of the interfaces that was necessary. So if you look from a software engineering perspective, we did some missionary work with electrical and electronics engineers in order to come to a common approach and a harmonized approach. So there is a complete continuous integration environment available within the project, and that's some of the things that you can plug in very easily. Well, for ICT engineers, it's very important to start with a system with which you can write a hello world application. And one of the use cases that we were focusing on in the beginning is to show the hierarchic concept. So what happens with a big virtual power plant cluster with a number of entities in case there is a redirection, there is an event in the grid, and that leads to a new topology that we can support using the coordination package. So that's more or less a kind of Hello Dream application that we were looking at and implemented during the beginning of the project. And we used the continuous integration to verify all the rollouts of the Dream project further on. So we used the grid manager also extensively. So it's an integration place and also allows to play scenarios, and also a test site for cooperation. So currently we are finalizing a joint use case in which we try to, additional to the 22 that we started with, in order to combine all the aspects of real-time operation, of day-ahead operation, but also the limited time operation on imbalance markets. So that's basically the last step that we're currently undertaking. So that's the status at this moment. So we've developed a first version of the and also subsequent versions of the framework, and during the project we used an evolutionary approach to adapt to all the different requirements coming out. So that's basically the working package 5, which was providing the basis for all the interaction within the Dream framework.
Thank you, Renè. Great. Big applause.